Hello all, welcome to this lecture where we are going to discuss what are the various machine learning problem types and what are the various learning types and techniques you can use to solve that problem. Okay, in order to achieve this, firstly you need to check what kind of data or data set you have. If it contains labeled data, which means it has proper labels like whether it is spam, whether it is fraud or not fraud, if you have such data, then you can go for supervised learning. And if you don't have such labeled data, then you need to go with unsupervised learning. And within these two categories as well, you have various options. In supervised learning, you can take learning type as categorical or you can go with continuous based on the use case. And within categorical, you can go for classification technique, like whether to classify whether it is fraud, non-fraud and all of that. And within continuous, you can use regression, wherein you can use regression, logical regression and such techniques to identify the output. And going to unsupervised learning, you can have discrete groups wherein you can create clustering techniques and build model out of it. And for outliers, you can use anomaly detection techniques to build machine learning model. So at a high level, this is how you identify which type of machine learning technique you should be using to build the machine learning model. And let's get into details of these techniques one by one, and we'll start with classification models. So classification models are part of supervised learning. And over here we have a couple of options. First one under classification is binary, wherein if you take the example of email dataset, whether it is spam or not spam, so these are the two binary options available. So your model output would be either the email is spam or not spam. The next option in classification is multiclass. Over here the output need not be binary, it can have multiple options. Let's again take example of email dataset. Over here it can be classified as promotion email, work email, updates, or social media email. So in such use cases, multi-class classification ML model should be used. Now next technique in supervised learning is regression. We saw an example earlier like ice cream sales with respect to temperature. So that is also a regression example. However, there are multiple options available in regression as well. Let's discuss them one by one. The first and basic regression type is simple linear regression. Over here the use case would be predict ice cream sales based on temperature. And the input variable or feature would be temperature, which would be either in Celsius or Fahrenheit. And dependent variable or the target is ice cream sales in dollars or units. And the outcome is to predict ice cream sales based on temperature. So this is a simple linear regression where there is only one input feature, which is temperature. And the next regression type is multiple linear regression. Here the use case is predict ice cream sales based on multiple factors. So multiple factors is important here. And what would be the variables or features here? Like temperature, day of the week, whether it is a weekday or weekend, and whether it's holiday or no. So there could be multiple features which would contribute in predicting the outcome. And again, the output is expected to be ice cream sales in dollars or units. And outcome is predict sales based on multiple factors. Lastly, logistic regression. Here the use case would be predict whether ice cream sales will exceed $500. And here again the features could be multiple like we had in previous example. And the only difference is whether the sales would exceed $500 would be your output. So the answer would be binary, yes or no. And the outcome, as we said, is a binary outcome. So that's it in regression. And that's it in supervised learning where we saw classification and regression. And now we'll move to unsupervised learning. Over here, there are two techniques available. The first one is clustering and the next one is anomaly detection. Let's start with clustering. And over here, unlike supervised learning, where the data has labels or known outputs, clustering algorithms work without predefined categories, allowing the model to find patterns or groups in the data on its own. So clustering is a type of unsupervised machine learning technique used to group similar data points together based on their characteristics or features. So the objective over here is to organize data into clusters, where data points within the same cluster are more similar to each other than to data points in other clusters. And to achieve it, it uses distance matrices, wherein most clustering algorithms rely on distance measures like cosine similarity to assess how similar or different data points are. Points that are close to each other are grouped together. And one example of this is k-means clustering, which divides data into predefined numbers, which is k, number of clusters, by finding k centroids, which is like center point, and assigning data points to the nearest centroid. Let's understand this more with an example. So we'll take an example of ice cream sales, and over here we'll try to cluster the regions based on temperature profiles. So the data is from different sales locations, including average temperature and total ice cream sales. And the features used here would be average temperature at each location. And what is the goal we are trying to achieve? We are trying to segment locations into clusters with similar temperature profiles. And the outcome we are expecting over here is the algorithm will group locations into k clusters based on temperature. For example, one cluster may represent cold region, wherein the sales is expected to be low, and another region may represent hot region, wherein sales are expected to be high. And this will help to target marketing efforts and predict the sales outcome. That's it in clustering. Let's move to other aspect of unsupervised learning, which is anomaly detection. Anomaly detection is a technique used in data analysis to identify unusual patterns or observations in a dataset that differ significantly from the norm. These unusual data points are referred to as anomalies, outliers, or exceptions. There are various techniques. Let's discuss them one by one. First one is statistical methods. Use statistical tests and models like z-score, Gaussian distribution to identify points that lie outside a defined range. Next is machine learning methods. Over here, the machine learning does not require labeled data, and algorithms such as isolation forest find patterns on their own. Next is proximity-based methods. KNN or K nearest neighbors is very important concept, and over here it identifies anomalies based on their distance to other data points. Points that are far from their neighbors are considered anomalous. So KNN is important. Don't confuse it with K-means. So these are two different techniques. KNN is for anomaly detection and K-means is for clustering. Now let's see an example of anomaly detection. Over here the graph displays website traffic over 100 days with daily visitor numbers. Blue line represents the normal website traffic behavior. Red dots highlight anomalies, which are days with significantly higher or lower traffic than usual. Anomalies are detected using z-scores, which measure how far traffic deviates from the average. How does this help? So anomalies might indicate unusually high traffic, maybe due to promotion or event, or unusually low traffic, maybe due to outages or issues which you want to tackle it. So that's pretty much in this lecture, where we saw what are the various machine learning problem types and what are the techniques you can use and machine learning models you can use to solve them. See you in the next one. Thank you. Bye.